Hi guys, welcome back to my channel Pirai Academy. In this series of data structure playlist, today we are going to see about queue implementation using linked list. And for this video, you want to know about queue basics, like its short introduction I have given in the previous video. Just go and watch it. I will be giving that in the description. Okay. So here you can learn about ADT. This should be important. And then you also want to know about linked list, especially singly linked list. That's enough. Okay, if you don't know about the singly linked list, I also recommend you to just go and watch this singly linked list video. I'll be giving this also in the description. So these two are the prerequisite for this particular video. And after learning this, you can continue with this video. So okay, go and learn that and continue. Okay, fine. Now let's get directly started with the logic. As you know about queue and the operations like enqueue, dequeue, and how the queue will be working. Okay, fine. Now initially we will be having two pointers. One is front and another one is rear, as you know. So this front pointer will be equal to null and this rear pointer will be also equal to null at initially. And we are doing some set of operations, for example, and in implementation of this queue using arrays, it will be fixed. But in linked list, it will be not fixed. Understand that? Okay, it is not fixed length. So we can add as much as linked list, as much as the memory of the CPU or memory of that particular compiler. Okay, so front is equal to null and rear is equal to null. So for example, I am doing some set of operation like enqueue of, for example, 3. Okay, then what I will be doing, I'll be creating a new node. Called 3. Its data will be 3. Okay, as you know that if there is a linked list node, then it will be having a data and its next. So that's why I want you to understand the singly linked list concept. Okay, now here there is a data of 3 and its next address will be initially null. If you want more than this, I can write here, just a minute. Okay, so here it will be 3 and its next address will be null initially. Okay, now this front and the rear will be pointing now here, will be not equal to null, but it will be pointing here, like, hey, this is the first node we have and it is the last node we have. That scenario. Okay, fine. Now in next step, I'll be just enqueuing of, for example, 4 or 14. Okay, 14. Then I'll be just making a new node of 14. Okay, and null. And I'll be just making my rears next. What? This null. Instead of this null, I'll be making this address. For example, if its address is, for example, it is 200, then I'll be making this null to 200, which means I will be having like this a linkage between them. And now I'll be moving this rear to here. For convenience, I am writing R. Okay, now it will be moved to here. Can you understand this? Now again, for example, if there is a enqueue operation of 20, for example, then again what is going to be the step? Create a new node called 20 and just make my rears next to this address. For example, if this address is 1000, okay, make here as 1000, so that there is a linkage between them. And then now it's time to make this to come here. Can you understand this? Yes. Okay, now let us go with some other operations like dequeue. If I am doing dequeue of, just I'm calling this function, then what should it happen? We want to remove the first element. What is the first element? This 3 is going to be the first element because it is added at first. Can you understand this? So I want to return this, or either print it or return it. Then I want to move my friend to the next node, which means I'll be just returning this 3 out. Okay, and then what I'm going to do is I am taking this as some temporary variable. And moving this friend to here. Okay, now I will be deleting this temporary variable, this entire node. I'll be deleting this entire node, so that now, as of now, my linked list will be of 2 nodes, only of 2 nodes. Hope you understand till now. Now, if I use peak operation, what is the peak element, which is the top element? Then now I will be just returning the front value. What is the front pointer's value? So here the front pointer's value is 14. So I will be just returning 14. Hope you understand this. And don't want to move any changes in this pointers. Okay. If for example, if the front is equal to null and rear is also equal to null, in that case you want to just return in these both operations like hey, this queue is empty. That's it. You understand this? Okay, let me just proceed with this for 2 times. Okay, so DQ operation, again a DQ operation, again a DQ operation, two operation. At first operation, this front will be moved here. Yes. As of now, here also the temporary variable will be here and it will be deleted, as you know. Okay. Now listen this carefully. This is going to be the main step. Okay. Again, we are doing a DQ operation, which means I want to just take this as temporary variable and make this to next. Next is what? Null, or also none in terms of Python programming. So here I'm focusing on only on logic, not on coding. Okay, so it will be coming to something like null. Okay, so when the front becomes null, automatically you want to change this rear is also equal to null, which means if we are dequeuing some value in the queue and it is the last element, then automatically change the front and the rear into null. Okay, and delete this temporary variable. Okay, if again I am doing a DQ operation, in this case it will be telling like hey, queue is empty. If I am doing peak operation, then also it will be telling hey, the queue is empty. Now hope you understand how we are going with the linked list implementation for that queue. Okay, so this is quite easier than the array, right? So linked list will be easier than array implementation. Yes, and it is also memory efficiency also. There we have 2 types, like in DQ. If you already saw my implementation using array for the queue, then you know that there are 2 types of implementation in the DQ method. Okay, there one is space efficient but it is time inefficient. Another one is time efficient, meanwhile space inefficient. But here it is both time efficient and space efficient. So telling about the time complexity, tell me what is the time complexity taken for each and every operation. First of all, NQ operation, what is the time complexity it is taking? O of 1. Why? Because we are just adding one extra node and we are just connecting that to it. That's it. Yes. Okay. Now DQ operation, it also O of 1 because we are just moving the front node and deleting its previous node. That's it. Yes. Okay. Now what is the peak operation time complexity? It also O of 1 because we are just returning the front element. That's it. So all the things will be done in a constant time, and space complexity will be the size that differing in this linked list. That's it. So this is going to be your time and space complexity analysis. In next video, we can see the code implementation of this same logical implementation. Okay, if you really like this video, subscribe to my channel. Don't skip any videos in this playlist because all videos will be helpful once you are applying for the competitive programming. And if you have any doubt in this video, you can ask in this comment section. I will be just commenting it out as an answer, or I'll be putting an individual video on it. Thank you.